Hi, today we are going to talk about some double angle identities and also half angle identities, and we're going to use those to solve problems. So please pause your computer and write these. All right, so we're going to use the double angle identities to solve a problem, and it's going to be very similar to the kind of problems we did yesterday. We are given that cosine of A is in the third quadrant, so I'm just going to draw that down there, and draw in my right triangle, and therefore this must be 4 because it's adjacent. The hypotenuse is 5, and again it's in the third quadrant, and I can find that this must be 3 using Pythagorean theorem. And the reason I did that is because that I want to use these identities. Sine of 2a is equal to 2 sine of a cosine of a, and then I want to use an identity for cosine of 2a as well. I have 3 to choose from, and I think I'll use this one, 2 cosine squared a minus 1. Now, in order to solve this problem, all I have to do is solve in what I'm given. I'm given cosine of a. I also need to know sine of a in order to solve this problem, and looking at my drawing above, I can do that. Sine, again, in the third quadrant is negative, so sine must be negative 3/5. And again, remember the hypotenuse is never negative. So let's go ahead and substitute in. I'll put a 2 here. Sine of a, again, negative 3/5. Cosine of a was given. It is negative 4/5. And then I'm going to simplify. That becomes, let's see, negative 3 times negative 4 is positive 12 times 2 is 24. And 5 times 5 is 25. Okay, so we'll substitute in also for cosine of 2a. 2 cosine squared. Remember, cosine is negative 4/5. Square it, subtract 1, and then we're going to simplify. That will be equal to 2 times 16 over 25 minus 1. And 2 times 16 is 32 over 25 minus 1. That's 32 over 25 minus 25 over 25. And that is, which is 7 over 25. And the last part asks which quadrant 2a is in. Well, you'll notice that sine is positive, which means it has to either be in the first or the second quadrant, and cosine is also positive. Positive cosine is in the first and the fourth quadrant, so therefore cosine of 2a must be in the first quadrant. Next, I want you guys to try this, and then pause the computer, and then I will show you the answers. Here are the answers. If you got something different, go back and check your work. If you are still having trouble, let's talk about it tomorrow. And here are the half angle identities. Please pause your video and write these down. And we're going to use those to solve some problems. So the first one I'm going to find is sine of a over 2. And we're going to use the identity sine of a over 2 is equal to plus or minus the square root of 1 minus cosine of a over 2. And we're going to use the 1 for cosine of a over 2. That's equal to plus or minus the square root of 1 plus cosine of a all over 2. Now, we know the cosine of a, so we can just simply plug in for that. One minus cosine of a, 3/5 over 2, and then this is plus or minus the square root of 1 plus 3/5 over 2. Now, we need to simplify this further. And 1 minus 3/5 is 2/5. And again, that's all over 2 plus or minus. And then we will divide and get plus or minus the square root of 1/5, which then is plus or minus root 5 over 5. Now you may be asking, well, which is it? Is it positive or negative? So in order to decide that, I need to go back and look at my constraint here. It told me that A is between 270 degrees and 360 degrees. That is the fourth quadrant. Well, I could take this whole thing and divide by 2. 270 divided by 2 is 135, and 360 divided by 2 is 180. So A over 2 is in the second quadrant. Now, in the second quadrant, sign is what? It is positive. So the answer for sign of A over 2 is going to be the positive. And I'm going to have a positive root 5 over 5. Now, for cosine, again, I'm going to simplify. 1 plus 3 over 5 is 8 over 5. And then, again, that's all over 2. Simplifying further, we get plus or minus 4 over 5. And again, simplifying further, I'm going to have plus or minus 2 over root 5. If I rationalize that, that becomes plus or minus 2 root 5 over 5. And again, we've got to think about which quadrant we're in. In the second quadrant, cosine is negative. So therefore, I know the cosine of A over 2 must be negative. Now, I can also use these identities to find exact values, just like I did yesterday, and only I'm going to be using my half angle identities. So the very first thing I'm going to do is think, how can I write tangent of 15 using angles that I already know on the unit circle? Well, let's think. We know the 30-degree angle, correct? Well, 30 over 2 is really just 15. So I am going to write tangent of 15 like this. I'm having trouble with my mouse. Tangent of 15 is equal to the tangent of 30 over 2. And I'll use that identity that I have for tangent of A over 2. That's going to be equal to 1 minus the cosine of A, cosine of 30 over sine of 30. And that becomes 1 minus, and now remember, cosine of 30 is root 3 over 2, and sine of 30 is half. Simplifying further, this becomes 2 minus root 3 over 2, again, all over a half, and then that becomes 2 minus root 3 over 4. And there is my exact answer for the tangent of 15. Here's another problem to simplify. My goal is to get this to look like one of the identities I already know. So I'm going to take this and I am going to factor out a 3 and write this as 3 times the quantity, 1 minus 2 sine squared 15. Now, this looks an awful lot like an identity I know. Let's see. That one looks like this. 1 minus. Doesn't this one look like cosine of 2a? It's one of the double angle identities for cosine. So looking at this, I can see that this must be the double angle for cosine, and I can substitute in and get 3 times cosine of 30. And of course, I know that cosine of 30 is root 3 over 2. So simplifying, I get 3 root 3 over 2. So that would be the answer in the most simplified form. which looks a lot simpler than what I had started with. Now, the next one, I want you to give a try, and then I will show you the answers. So pause your video, and then you'll see if you got it correct. And I have the work shown here for you. The goal is to get it so that what you're starting with looks like one of the identities. And you can see that I wrote the double angle identity for sine right here. And then I noticed I would just then have to multiply this by a half. So I continued on to simplify, and this became sine of pi over 4, which of course I know is root 2 over 2. That gets multiplied by half, and then I'm left with root 2 over 4. If you have trouble with this, go ahead and look it over again. If you still have questions, we'll talk about it tomorrow. And that would be the lesson for today. So tomorrow we will continue to work on the same kind of problems we did today with these additional identities. I'll see you then.